We praised Halley's Comet for its punctuality. We know its orbit and expect it back in 2061 like clockwork. But then there are the Great Comets. They don't work on a calendar. They just fall out of the Oort cloud, which, if you don't know, is a giant icy junkyard at the very edge of the solar system and dominates half the sky. These great comets are so massive and spew so much dust and gas that their tails stretch for millions of kilometers. Sometimes the coma itself gets so bright that you can see the comet in broad daylight. That's what happened with Comet Hale-Bopp in 1997 or Comet McNaught in 2007. But here's the problem. Astronomers cannot predict their arrival in advance. These objects fly in on extremely elongated orbits out of absolute darkness. We are physically incapable of tracking them early. For example, we'll spot the next one of these giant ice mountains just a few months before it ignites in our sky view, and that's at best. Meaning, right now, a chunk of dirty ice the size of a metropolis could already be hurtling towards us. Ooh, scary. We have no idea where it is, and we have no exact date. But statistics are relentless. Great comets appear, on average, once every few decades. So the odds of seeing one in your lifetime are quite high. Just keep looking up. You won't need binoculars for this next event on our list. In fact, you won't see it at all. You will feel it as silence. The Voyager 1 and Voyager 2 probes are currently the most distant human-made objects from Earth. They've been flying through the void for almost 50 years, have already left the heliosphere, and entered the interstellar medium, becoming our only eyes in interstellar space. But those eyes are closing. To transmit data across billions of kilometers, you need power. Solar panels are useless at this distance. To the Voyagers, the sun looks like just another bright star out there, and its light couldn't even power a pocket flashlight. The only thing keeping the onboard systems alive is the heat from decaying plutonium in their nuclear batteries. The problem is that physics is unforgiving and relentless. Plutonium decays on its own, and with each passing year, the batteries generate less and less electricity. Sadly, their remaining power is slowly running out. NASA engineers have spent years saving every single watt possible, taking turns shutting down scientific instruments and heaters just to scrape together enough power to keep the antenna running. But roughly in the late 2020s to early 2030s, communication could cease entirely. The power levels will drop below the critical minimum required for radio transmission. There will be nothing dramatic like an explosion or a collision, though that would be pretty cool. Instead, receiving stations on Earth will simply lock onto that last and final data packet, and then the signal will fade forever. Humanity's most distant envoys will become silent chunks of metal, continuing their endless flight across the Milky Way in complete silence. Usually, astronomical events demand patience. You drive out of the city, you stare at the night sky for a couple of hours just to catch one faint streak of a meteor. But in November 2032, or 2033 according to some calculations, you won't have to squint. Earth will plow straight through a dense section of the dust trail left by the delightfully named Comet Tempel-Tuttle. And this won't be your average meteor shower. We're looking at a massive spike in Leonid activity, potentially reaching storm levels. Essentially, our planet will slam headfirst into a wall of cosmic dust at immense speed. In moments like these, the meteor count jumps from a modest 10 per hour to thousands. The sky will literally look like it's falling. During the peak minutes, hundreds of objects will burn up in the atmosphere, densely crisscrossing the entire visible sky with glowing lines. This phenomenon looks so massive and terrifying that back in the 19th century, during a similar storm, people poured into the streets, convinced the stars were crashing down to Earth and that the apocalypse had finally arrived. There will be no apocalypse this time, but we will witness firsthand what it looks like when a planet rams head-on through a wall of cosmic debris. Saturn is the icon of the solar system. We know it almost exclusively for its massive rings. But in October 2039, orbital mechanics will pull off a massive optical illusion. Despite the gigantic width of the icy ring structure, their average thickness is surprisingly tiny, just tens of meters. In 2039, the planet will tilt towards Earth in such a way that the rings will be perfectly positioned edge-on to our line of sight. At a distance of 1.5 billion kilometers, such a thin edge simply won't be able to reflect enough light back into our telescopes. The rings will visually vanish against the black backdrop. For a few weeks, the gas giant with its complex orbital ice system will turn into just a basic-looking, utterly unremarkable yellow orb. It's a flawless magic trick on a planetary scale that will have amateur astronomers around the globe wiping their lenses trying to figure out where the solar system's main attraction went. We're used to planets being randomly scattered across the night sky. Seeing even two of them close together is considered a stroke of luck. But on September 8th, 2040, orbital mechanics will line everything up with frightening precision. Mercury, Venus, Mars, Jupiter, Saturn, and the thin crescent of the Moon will huddle together in an incredibly tight grouping. To an observer on Earth, it will look as if someone artificially compressed the solar system just to fit all the major worlds into the lens of a single pair of binoculars. In reality, it's not a straight line, nor is it a true physical alignment in space. It's just a rare, beautiful projection of the planets onto one patch of the sky. Millennia ago, a clustering like this would have guaranteed panic, with people viewing it as some kind of harbinger of civilizational collapse. Today, we know it's just gravity and orbital cycles. Or is it? But considering what we're moving on to next, a premonition of disaster doesn't seem entirely unfounded. Low Earth orbit is overcrowded, packed with tens of thousands of satellites tearing around the planet at 28,000 kilometers per hour, and more are added every single month. Back in 1978, NASA consultant Donald Kessler calculated and predicted this exact scenario. He proved that if the density of objects in orbit exceeds a critical mass, collisions will trigger an irreversible process. Today, that scenario bears his name, the Kessler Syndrome. A major collision will create thousands of small fragments. These pieces of metal, traveling 10 times faster than a bullet, will start shredding neighboring satellites. Those will explode into new fragments. The shrapnel will multiply exponentially, and the space around Earth will turn into an orbital meat grinder. From Earth, it'll look like a beautiful artificial meteor shower. The night sky will regularly flash with burning debris. But in reality, it'll mean a global system failure. Navigation, communications, network synchronization, and a massive chunk of the global economy will take a severe hit. In the worst part, a dense cloud of fast-moving debris will heavily complicate the launch of new rockets for decades to come. We could be building a deadly barrier around the Earth with our own hands. And to drastically accelerate this cascade, all it takes is one major collision in an overcrowded orbital zone. But even if we save our satellites from the debris, the sun might just burn them up anyway, and also shut down a couple of continents while it's at it. We tend to think of our star as a stable source of light, but periodically it spits billions of tons of magnetized plasma into space, what's called a coronal mass ejection. In 1859, one of these plasma clouds hit Earth dead-on. It went down in history as the Carrington event. The sky lit up so bright that, get this, you could read a newspaper at night, and telegraph stations sparked and caught fire on their own. In the 19th century, electricity was just a fun novelty. Today, our civilization is totally dependent on power grids and the digital web, and experts consider a repeat of a Carrington-level event to be a matter of when, not if. Statistical cycles of solar activity suggest there's a high chance we'll see one by the year 2100. The good news, there will be no Hollywood-style global apocalypse. We have tracking satellites that will give us anywhere from 15 hours to a couple of days to prepare. Power engineers will have time to preemptively shut down vulnerable parts of the grid. The bad news, that absolutely will not save everything. A few hours before impact, we'll see blood-red auroras stretching all the way to the equator, and then the magnetic storm could cripple our power grids across massive territories. And here's the catch. Replacement transformers don't just sit in warehouses. They are custom built and take 6 months to manufacture. Uh-oh. We won't be sent back to the Stone Age permanently, but entire megacities could be left without stable electricity or communications or even water delivery for months on end, all simply because our star let out a tiny burp. If the sun hasn't crippled our power grids by 2093, it'll at least put on one final visual spectacle for us. In part 1, we talked about the total solar eclipse of 2027. That's when the moon perfectly covers our star. But on July 23, 2093, orbital geometry will play out a bit differently. The moon will be near its farthest point from Earth. Its disk simply won't be big enough to hide the entire sun. So instead of the usual darkness, an absolutely black sphere will hang in the sky, framed by a blindingly bright plasma rim, a ring of fire. And it will hang there for a terrifyingly long time. This event will be one of the longest annular solar eclipses of the 21st century. It's a perfect, cinematic, and slightly ominous shot to the end of the century. Just make sure you don't look at it without filters, because that fiery rim is still perfectly capable of permanently damaging your eyesight. All of the previous events on our list had at least some benchmarks: orbital mechanics, cycles, dates. Betelgeuse doesn't have a schedule. Look at the constellation Orion. Hanging on its left shoulder is a massive red supergiant. By stellar standards, this star is in the final stage of its life. It's running out of fuel in its core and is just barely hanging on by a thread. When gravity finally wins, the core will collapse and a supernova explosion will occur. This won't just be a bright flash in a telescope. In our sky, it will rival the moon or the brightest night sky objects in luminosity. Think about that. For several months, Betelgeuse will become so bright, it'll even cast soft shadows in the dead of night. And get this, it'll even be perfectly visible in broad daylight. At this point, it's logical to panic. And think, won't we get fried by radiation from this exploding star system? Spoiler alert, nah. Betelgeuse is roughly 600 light years away from us. By cosmic standards, those are perfectly safe front row seats. The lethal radiation will simply dissipate in the void before it ever reaches our lovely planet Earth. In fact, the only notable impact might be on the behavior of animals sensitive to light cycles like migratory birds and insects. But for humanity, it'll be a perfectly safe VIP screening of an epic scale event. But the main catch is something else. We don't have a timer. Astronomers say the explosion is expected within the next 100,000 years. In the lifespan of the universe, that translates to any second now. By the way, remember, due to the delay of light, the star easily could have already exploded back in the Middle Ages, and the light from that explosion has been flying towards us the entire time. So, the greatest astronomical show of the millennium could begin in a couple of centuries, or it could ignite right now while you're scrolling through the comments under this video. Alright, that's it for now. Don't forget to subscribe to the channel and hit the bell. Now, quickly, before Kessler Syndrome leaves us without any internet and Betelgeuse cancels the night.